Hello, Algebra 2 students. Today we're going to look at some more examples. So my class tried these as a warm-up. I think if you can do like about 2 out of the 4 of these after the first day's lesson, you're doing really well. To get all of them completely by now, that would be doing extremely well. So let's go ahead and look at each one. So, number 1. What property should we use to begin number 1? Suggestions? The power property, the one that brings that 2 down from its tower, right? So let's bring Rapunzel out of the tower, bring this down in front. There's already a -7 there, so I think those things are going to get multiplied together. So what are we going to have?
Collection.
Yeah.
Thank you.
Okay, thanks. Like so? Okay, I think that log base 2 of 256 is just something we should be able to count. What is that? The 8th power of 2 is 256, so this is 8, right? That's the way we think about it. So we've got -14, and that thing is 8, so it's times 8. So we just got to multiply 8 and 14, so that's what, 80 and 32? 8 times 10 is 80, 8 times 4 is 32, so that adds up to a -112. Sweet, so that guy simplifies all the way down to -112. All right, I think that one wasn't too bad. Nothing bad in there. Number 2. Number 2, there's one thing you've got to do first. If you don't do that thing first, you're kind of going to be a little bit lost. So what is the thing that you absolutely have to do first on number 2? You want to combine these ultimately because they're both base 8, and this one's going to be like 0 point something, and who the heck knows what that one's going to be right now. But before I try to combine them with that property, that tool that we learned yesterday, what do I have to move? I have to move the 3. The 3 in front of this kind of screws it up. So where can I move it? To up in the tower. So it's like the reverse of that one, right? This one we pulled the young lady out of the tower. This one we're putting someone up there that we don't like. So we're going to have logarithm base 8 of 3 cubed. We'll just leave this one alone for now, but I'm going to write it out as one separate step so that I don't make any mistakes. So that's 27. And you didn't have to write it out this much, of course. But it really helps now because if you do write that out, you can see that when I bring these together into one logarithm using the property, the sum to product property, right? Taking a sum, turning them into a product inside of a single logarithm. You're going to have 27 times 512 over 27, and you can see that I engineered this so that what would happen? So that these would cancel out, and you'd be left with logarithm base 8 of 512, which, though it's not reality, I still don't think we're quite ready for reality. It is something you should be like, oh, 512, I've seen that before. What is 512? It's the 3rd power of 8, right? So base 8 to the 3rd power is 512. So when the logarithm base 8 eats 512, you get 3. Okay? I think number 3 is really similar to that. So if you could do number 2, you should be able to do number 3. So if you didn't get number 2, why don't you try number 3 now? I'll pause. And same thing, if you're watching the video and you didn't get number 2 as a warm-up, now try number 3 because it's about the same exact thing. Okay, so let's look at this. We'll see how similar it is to number 2. So what do we have to move first, class? That 2. It's kind of in the way of using the log property to combine the base 4s. So instead of having it there, let's just move it. I'll just write it, erase it, and put it where it's supposed to be. Move it up there. So 3 squared is going to be 9. Right. Get a blue. So this is going to combine to one logarithm base 4. Minus becomes what in log land? Comes division. And I'm going to be dividing that by 9. Because 3 squared is 9. Just like on that other one, Jordan. Yeah. Okay. So 2,304 divided by 9. I have no idea what that is. Can you guys help me? 256? Once again, I think I made this come out nice. 256, you should be remembering, is what power 4? It's the 4th power. 4 to the 4th power is 256. So that mass simplifies to just 4. Pretty nice. All right, number 4, like I said, is pretty challenging at this point. I think we can do it though. At least you can follow me doing it. With a little bit of practice, you could do something like it. So what's different about it, first of all, besides the fact that there's 3? We did ones with 3 pieces yesterday, so I don't think that's the issue. 0.001, I don't think that's a problem. But yeah, it is a little different, yeah?
It has a different base.
Ah, one of them has a different base than the other 2. This has base what? 10. If it doesn't say it, it's base 10. Those have base 5. So I think you've got to think about this piece separately from those 2. Does that make sense? So let's do this piece separately right now. I had a bunch of people ask me this question about the assignment in class this morning, so listen better than they did. If you have a decimal in log land, it's always best to turn it into a what? In fact, in most algebra lands, that's true. Not always, but most of the time, especially in log land. So, 0.001, what is that? Well, 0.01 is 1%, so that'd be 100th. So this is 1,000th. I think we've even done this one a couple times already. Okay, I'm just going to let the other guys chill for a second. So what power of 10 is 1 over 1,000? Well, 1,000 is what power of 10? 3. Since it's reciprocal, it's -3. Okay, that one's done. Don't worry about that anymore. And we can just focus on these. So which log property, be cautious, do I want to combine these? I'm guessing most of you would think the subtraction or difference to quotient property, the one that uses division. And if you're thinking that, that's not bad thinking, but it won't work here. The reason is you have a sneaky distribute thing. This is like a sneaky transformation. That negative is not only affecting this logarithm, it's very covertly affecting this logarithm as well. So if we have something like that, when we did sneaky transformations, we factored out the sneaky part. What do they share? They share that negative. Pull it out. See what's left. Well, it really doesn't change what these things are, but it changes this minus to a plus. It's a little bit, I would say more than a little bit sneaky as to why that needs to happen. But the idea is you're trying to combine these two things. The only other way to handle this situation, there are other ways, is this negative is attached here, right? It's just like the 2 that was there or the 3 that was there. It's fouling the property up. It's kind of like you have a wrench, but it's stuck in your tool belt. You can't pull it out yet, you know what I mean? So by factoring, I was able to pull it out. Now I could just use the sum to product property. So I can say this is going to be log base 5 of 3 times 41 2/3. So 3 times 41 2/3 might be something you guys aren't real comfortable entering in your calculator. So I'm going to see if I can roll my calculator out here and get that to come out by saying. So here's how I would enter that in my calculator. 3 times, then I'd put a parenthesis, and I'd go 41. How do I put 2/3 in the calculator? You could do alpha stuff, that's fine, but how do you combine it with 41? Plus. That might seem obvious to some of you, but it wasn't always obvious to me. And so since it's just 2/3, I don't even have to be careful. I can just say 2 divided by 3, and I'm good. So that's going to be 3 times 41 2/3, which came out nice. So that should come out to 125. And remember, we've got this other stuff chilling from the separate computation we did. But this is an easy logarithm. What's it come out as? Just 3. So we've got 3 for this, and we're taking that away from -3. So our answer is, of course, -6. So there's some more examples, and a little bit tougher examples of using basic logarithmic properties. Man, these are going to be prevalent all over the place in the future. See you next time.